Hello, so in today's video, we're going to look at solving trigonometric equations. So particularly today, trigonometric equations where you have this linear function within this trigonometric function. So for example, sine of 3x plus 1 equals 0.5, cos of 2 minus x equals root 3 over 2, and tan of 2x minus 3 equals minus 1 over root 3. So in particular, we're going to look at solving equations for x whereby you've got a linear expression of x within a trig function. So that's kind of what the focus is for today's video. So we'll start with the first one here. So with this first one, we want to solve sine of 3x plus 1 equals 0.5 with x values between 0 and 2 pi. So we want to make sure that our final solution or solutions will be between 0 and 2 pi. So that's what we want to do with this example here. So how would we solve this? So I guess the first step is to invert this sine function so that we try and obviously we're trying to calculate x. That's the whole point of this equation. We're trying to find the x value. So let's get rid of the sine function. Let's apply the sine inverse to both sides. So if we do that, we get 3x plus 1 is equal to sine inverse of 0.5. Now we should know that sine inverse is 0.5. If you do that on your calculator, or if you know your trig exact values, you'll know that you'll get 3x plus 1 is equal to pi over 6. And that's because sine of 30 degrees or sine of pi over 6 radians gives you a half. So you should get pi over 6 in your calculator if we're dealing with radians as we are in this question here. I'm just going to move this to the side. Now, we've got to actually think about our domain of values here for x here. So we know that x is to be between 0 and 2 pi. So let's think about what 3x plus 1 has to be between. So what we can do now is we can use this here, and then we can multiply everything in this inequality by 3. So 3 times 0 gives you 0. So 0 must be less than 3x, which is less than 6 pi. So multiplying that by 3, that by 3, that by 3. And then we can add 1. So we can say that 1 must be between 3x plus 1 less than or equal to 6 pi plus 1. So what this is telling us is that this thing here, this 3x plus 1, must be between 1 and 6 pi plus 1 in order for us to get a correct solution. So when we look at this number here, this pi over 6, now when you do pi over 6 in your calculator, it's roughly about 0.5. So roughly, I mean, if I do this on the calculator now, pi divided by 6, you get about, 0.524. Now this is too small. This is less than 1. So this is not in our domain. So not in domain, because we want 3x plus 1 to be trapped between 1 and 6 pi plus 1. So even though sin inverse is 0.5 is actually pi over 6, it's not within the correct domain of x values that we need to solve this specific equation. So this is not in domain. So we just need to think about our sine graph and think about what would be in our domain. So let's just draw like a rough sine graph. So sine obviously looks something like this, with a time period of 2 pi radians, 2 pi there, pi over just pi there. So then we know that half, sin minus 1 over half, sin inverse for half, half on the y-axis is about there, so that's half there. So this first value that we got there was pi over 6, so that was about 0.5. Now, what would this value here be if we go across on our sine graph? We get another value here, so we get this value there, which is pi take away pi over 6. Remember, this is symmetrical about this. So between 0 and pi, the sine graph is symmetrical with a line of symmetry between line of symmetry on x equals pi over 2, halfway there. So we know that this here must be pi take away pi over 6 here, and that's going to be 5 pi over 6. So that's 5 pi over 6 there. Now, is 5 pi over 6 between 1 and 6 pi plus 1? So let's do that on the calculator. So 5 divided by 6 times by pi. Yes, it is. So it's about 2.6. About 2.6. So yes, this will be in our domain of values because it's between 1 and 6 pi plus 1. So we're fine with this. So we can therefore say that 3x plus 1 can be equal to 5 pi over 6. So that's one value that we are allowed. I'll just put a tick by that just to emphasize we can have that one. Now, if we keep on going across on our graph, when y equals a half, Let's keep on going across and see what else we get. So we get this value here. Now this value again, because the sine graph has a time period of 2 pi radians, this, the gap between this number here and this pi over 6 there obviously is going to be 2 pi. Because again, you've got the sine graph repeats itself every 2 pi radians. So this point here is going to be 2 pi radians plus pi over 6. So 2 pi plus pi over 6, that should give you 13 pi over 6 there. So this is 13 pi over 6. Now it's 13 pi over 6 between 1 and 6 pi plus 1. So 13 divided by 6 times by pi. Yeah, so that would work. Yeah, so 13 pi over 6 is between 1 and it is between 6 pi plus 1. So we've got another value here. So our second possibility is that 3x plus 1 is equal to 13 pi over 6. We've got that one as well. We've also got another solution there as well. So this one here. Now this one is actually 2 pi radians bigger than this one here, this pi over 6 here. So the gap between there and there is 2 pi radians. So again, the sine graph repeats itself every 2 pi radians. So this point here is going to be 2 pi plus 5 pi over 6 on the x-axis. And if you work this out, so 2 pi is the same as 12 pi over 6. 12 pi over 6 plus 5 pi over 6, this would be 17 pi over 6. So we get that as well. Now again, is this between the number 1 and the number 6 pi plus 1? Yes, it will be. So it's about roughly about 2.2 pi. Again, that's between 1 and 6 pi plus 1. So we've got another solution as well. So we've got 3x plus 1 equals 17 over 6 pi. And we're going to have more as well. So I'm just going to try and make my writing smaller. I'm just going to try my best to bring this graph down with me, down to here. And we'll just continue the graph onwards because we are going to get more solutions. So continuing this onwards and onwards, the wave goes up and up like that. So yeah, we've got 2 pi there. I mean, this is going to be 4 pi. This is going to be 6 pi. And that would be 8 pi. Sorry, not 8 pi there. This would be 8 pi over there. So that would be 7 pi there. So we definitely want to stop. We don't want to go further than 7 pi because we want to go up to 6 pi plus 1. So we just got a few more solutions that we will have. We've got this one here, which is again between 1. The number 1 is like somewhere roughly like here, roughly somewhere there. So we've got to be between the number 1. We've got to get x values between the number 1, which we'll say. So I'll do this in a different color. The number 1 roughly there, so that's 1. 6 pi plus 1, I mean, it's roughly going to be there, 6 pi plus 1. And so therefore, as long as we get x values, like, for example, this one there, this one there, this one there, this one there, whatever that will be, this one there, whatever that will be, and this one there. So it looks like we've got 3 more just to work out. So to work out this one here, so this one is 2 pi bigger than this one here. So this is a jump of 2 pi. So we're just jumping up by 2 pi. So 13 pi over 6 plus 2 pi. So that's 13 pi over 6 plus 12 pi over 6. That's going to give you 25 pi over 6. So 25 pi over 6 there. And in fact, you're going to have another one here as well. So we may as well just do this jump here. So we're going to jump up there by another 2 pi. So 25 pi over 6 plus another 12 pi over 6. That would give you 37 pi over 6. So 37 pi over 6. And just to check that this is less than 6 pi plus 1, 37 pi divided by 6 is about 19.37. And then 6 pi plus 1 on the calculator is 19.84. So it's just a little bit less, so that's still valid there. So we've got 25 pi over 6 as another possible outcome, and we've got 37 pi over 6 as another possible outcome. And then we've got one more here, this last one here, which is 2 pi bigger than this this 17 pi over 6 here. So 17 pi over 6 plus 12 pi over 6, because remember 12 over 6 is 2, so that's 2 pi. So 17 pi over 6 plus 12 pi over 6, that would get you 29 pi over 6. So that's going to be our other one. So we've got, looks like 6 solutions. We've got that one, that one. We've also got 3x plus 1 equals 25 over 6 pi. We've got 3x plus 1 equals 29 over 6 pi. And then the last one, 3x plus 1 equals 37 over 6 pi. So in this question here, we get 6 solutions. I mean, normally in exam questions, you normally won't get as many as 6 solutions, so it won't really be as hard as this example here. But this is just really an example to demonstrate how you can solve these kind of equations. So then we've got our 6 solutions. We actually need to find the x values. So I mean, with the first one here, I'll call this 1, call that 2, call that 3, 4, 5, 6. So with this number 1, we've got, making x a subject to the formula there. Take 1 from both sides, divide by 3. You get x equals 5 pi over 6, take away 1 over 3. From number 2, you get x equals 13 pi over 6, take away 1 over 3. With your third one, you get x equals 17 pi over 6, take away 1 over 3. With your fourth one, you get x equals 25 pi over 6, take away 1 over 3. With your fifth one, you get x equals 29 pi over 6, take away 1 over 3. And with this final 6th solution, you get x equals 37 over 6 pi, take away 1 over 3. So they would be the 6 solutions. So if you had a question saying give your answer to 3 significant figures, you could just work these numbers out in your calculator and you would get your solution. So we get a solution there, we get a solution here, solution there, solution there, solution there, and a solution here. So all of these solutions will be between 0 and 2 pi, and you can check that on your calculator to make sure that that is correct. So yeah, they would be the 6 solutions for that first equation. So let's go to the next question. So this one is to solve this equation here between 0 and pi. So when x is between 0 and pi. So first of all, let's consider our domain of values. So inside the cos function here, we've got this 2 minus x. So I'm just going to firstly just put minus signs. We've got this negative x there. So let's think what happens if we put a negative sign inside the domain. So multiplying everything by minus 1, well, times x by minus 1, you get minus 1. Times 0 by minus 1, you just get 0. And then times pi by minus 1, you get minus pi. Now, when you multiply an inequality by a negative number, you have to flip the signs. So remember, you just got to change the signs around. So you'd actually get this instead. So you get, just to rewrite this, you get that minus pi is less than or equal to minus x, which is less than or equal to 0. And then we can add 2 to everything. So adding a number 2, we get 2 minus pi is less than or equal to 2 minus x, which is less than or equal to 2. So that's our domain of values that we've got to watch out for. So let's take the cos inverse and see what we get. So cos inverse, so 2 minus x is going to be equal to cos inverse of root 3 over 2. Now I know from my exact trig values that root 3 over 2, so cos of pi over 6, cos of 30 degrees, that's going to give you root 3 over 2. So I know cos inverse of root 3 over 2, that would give me pi over 6 radians on your calculator to get 2 minus x equals pi over 6. Now the question is pi over 6 within our domain of values that we need? So we need 2 minus x to be between 2 minus pi and the number 2. So 2 minus pi on your calculator, 2 minus pi, if I do that on the calculator, I get about minus 1.14 roughly. And this is obviously the number 2. So pi over 6 will be between those two numbers. So that is acceptable there. So that's fine there. So we've got one possibility there. Now we just need to think about our cos graph and think about what that looks like because we're dealing with the cos function here. So let's sketch a graph of cos, and I'll do this down here. And I'll include the negative, a little bit of a negative version as well, because we want to include a negative there. So our cos kind of goes like this. That's what our cos graph looks like. We've got 0 there. We've got pi over 2 there. We've got 3 pi over 2 there. And we'll stop there. So, I mean, well, pi is about 3.14. So we don't really need to go further than this 3.14 here. And again, minus 1.14, that's 2 minus pi. Now we know that this here is going to be negative pi over 2 and negative pi over 2 on the calculator. So pi over 2. Yeah, so this is about minus 1.57 here. So we don't really need to go further than here. We don't really need to think about values like beyond here. We can kind of ignore everything here. We can kind of ignore everything here. We're just worried about this pi here. So let's think about this. We've got root 3 over 2 as kind of like our y value on the cos graph. So root 3 over 2. So we're going to go roughly that. So what we've just worked out here is this value here, this pi over 6 value. That's the value we got there. So this was pi over 6. It looks like we've also got another one here. So I mean, if you go across here, you go out of the domain there. So we don't need to worry about going to the right. But if we go to the left, we've got a solution here. We'll just check what this is. So again, because this cos graph is symmetrical about this x equals 0 line, the gap between this pi over 2 and this pi over 6 here, this gap here, must be the same as this gap here. So this here, this number here, if I just try and fit this in here, this is going to be minus pi over 2 and then plus a pi over 6. Sorry, not plus pi over 6, sorry. Sorry, this is wrong. So because it's symmetrical, this is just going to be minus pi over 6 here. So minus pi over 6. Because remember, if this is pi over 6 there and you've got a line of symmetry there, then this also must be minus pi over 6. So that's minus pi over 6 there. Now, is minus pi over 6 in our domain? So negative pi divided by 6 on the calculator is about, yeah, again, so 0.524 roughly. So that is in our range. So it's between minus 1.14 and 2, because again, this is about minus 0.524. So therefore, it is in the domain of values that we need. So we've also got this second solution. So 2 minus x equals to minus pi over 6. We can now, we've got two solutions then. We haven't got any more with this one. We can now make x a subject to the formula. So with the first one, we get x is equal to 2 take away pi over 6. And with our second one, we get this, this solution here. So we get x equals 2 plus pi over 6. And again, if you put those numbers into your calculator, they will be between 0 and pi, because we want x to be between 0 and pi. So they would be the two solutions there, that one and that one. And again, I mean, if the question said, give your answer to a certain number of significant figures, you can just put those two solutions in your calculator there. So they would be the two solutions for that one. And then this final one here, this tan function. So again, we want to solve this equation. We want to find x when x is between pi and 2 pi. So let's think about the domain then. So first of all, let's times x by 2 because we've got 2x there. So we're going to times it by 2. So this means that we get 2x is less than or equal to 2 pi, less than or equal to 4 pi. And then we can take away 3. So 2 pi take away 3 must be less than or equal to 2 x minus 3 less than or equal to 4 pi minus 3. So again, if we just get like a rough approximation for this number here, 2 pi take away 3 is about 3.28. And this number here is about approximately, so 4 pi take away 3 is about 9.57 roughly. So we want to get, so when we take the tan inverse of this, we will get 2x minus 3. So 2x minus 3 is equal to tan inverse of minus 1 over root 3. Now, if you do this on your calculator, you should know that tan of 30 degrees or tan of pi over 6 is 1 over root 3. So tan of minus pi over 6 is going to give you minus 1 over root 3. So we should get here a minus pi over 6 there. Okay, so now is minus pi over 6 in our domain of values? No, it's not. It's not in the domain. So let's just write a note here, not in domain, because we want 2x minus 3 to be trapped between that number and that number. And in this case, it's not. So it's not in the domain because this is not trapped between these two numbers. So we've got to think about our tan graph. So what does our tan graph look like? and we're going between 3.28, so about roughly pi, and roughly here about 3 pi, roughly. So our tan graph looks something like this. So we've got these asymptotes at pi over 2 and 3 pi over 2 and so on and so on. So I mean this up here, that's 2 pi there. We want to go a little bit further. We want to go roughly up to 3 pi. So we'll just again draw the asymptote there. Continue with that there. So yeah, so this is going to be, so here would be pi. This would be 3 pi there. This would be 7 over 2 pi there, and 7 over 2, so 7 divided by 2 times by pi gives you about 10.99. So we don't really need to go further than this. This 7 over 2 pi there is where we need to go up to. So we don't need to go any further with the graph. So we've looked at our negative value. So we when we did this calculation, it's a tan inverse of minus 1 over root 3. So minus 1 over root 3 would be our y value, but basically, so minus 1 over root 3, like somewhere down there. So what we obtained on the calculator doing this calculation there was this number here. So we got that number there. Obviously, again, this is outside of our domain. So we just got to go draw a horizontal line, calculate this solution here. So the key thing about tan graphs that we mentioned in previous videos that I've done is that tan graphs have a time period of pi radians. So they just repeat themselves every pi radians. So to go from this one to this one, the gap here is going to be pi. And then to go from this one here to this one here, the gap there is going to be another pi. So another pi there. And then the gap to this one, again, this is going to be another pi there. So they just jump up in pi's, the tan graphs. So they're probably a little bit simpler than the sine and cos ones, because they just jump up and repeat themselves every pi degrees. So yeah, again, this one here was minus pi over 6 on the x-axis. We want to jump up by pi. So pi, minus pi over 6 plus pi, that's just pi take away pi over 6, which is just 6 over pi, sorry, 6 pi over 6 take away pi over 6, which is going to give you 5 pi over 6. You get 5 pi over 6 there. So let's just check, is that in our domain of values of 3.28 up to 9.57? So 5 pi divided by 6 on the calculator. Yeah, this is about 2.6. So it's a little bit too low. So just put a cross there just to make clear that we don't need that one. But we're going to need this one here. So this is going to be pi plus 5 pi over 6. So we're adding another pi to this number there. So plus another pi, because again, it repeats itself every pi degrees. So pi plus 5 pi over 6, that's going to be, so 5 pi over 6 plus pi, which is 5 pi over 6 plus 6 pi over 6. 6 plus 5 gives you 11. That's going to be 11 pi over 6. Now, 11 divided by 6 times by pi on your calculator gives you about 5.76. So that is going to be in our domain there. So we know that one solution from this is going to be, so I'll just write this here. So 2x minus 3 is equal to 11 over 6 pi. So that's, sorry, that should be a pi there. So that's one possibility. And then we're going to get this other one here. So add another pi, because again, the gap between here and here must be pi, because tan has a time period of pi radians. Add another pi. 11 over 6 pi plus pi is exactly the same as 11 pi over 6 plus 6 pi over 6, because 6 divided by 6 is 1. So 6 pi plus 11 pi gives you 17 pi. So you get 17 pi over 6 there. And 17 divided by 6 times by pi is about 8.9. That is in our domain. So we're fine. We've got this other solution as well. So we've got 2, sorry, I'll do this in black ink. We've got 2x minus 3 equals 17 over 6 pi. And then if we do go any further, if we add like another pi onto that, so 17 pi divided by 6 plus another pi, we go too far. We go to about 12, which is too big. So we've got these two solutions there. We just need to rearrange these to make x a subject to the formula. So with the first one here, you get x equals 11 over 6 pi plus 3 divided by 2. And then the second one, add 3 to both sides, divide by 2, we get 17 over 6 pi plus 3 divided by 2. So we get this solution there and that one there. And these two solutions would solve this equation with this specific domain there. So yeah, that was just a summary of how you can solve trig equations when you've got linear functions of x within these trig functions. So any questions or anything that you want to ask about these about my methods, or any questions with what I've done, please do put them in the comment section. But yeah, that's just how you would solve equations like this. You just want to make sure that you change your domain according to the input into your trig function, and then you can use your graphs, your trig graphs, to determine whether what you get on the calculator falls into your domain, and then you can use the graphs to find out the actual values that will fall into your domain. So yeah, again, that was just a summary of solving trig equations of this type. And again, any questions, please put them in the comments